Hello and welcome to Analytics. My name is Maxwell Adigwe. I am a data analyst. I like to call myself a data scientist as well, but I'll stick to data analyst based on this project. This project is basically on data analysis. Now, if you go to Kaggle, let's go to Kaggle. If you can see my screen, there is a data set there called stroke prediction data set. And I want to use this data set to explain the thinking process of a data analyst. So if you're a data analyst, if you're a data scientist, if you're someone who is taking this data analyst course, or if your job requires data analysis, please stick to this video. I will share some line of thought with you that can actually guide you in making decisions, in executing your job as fast as possible as a data analyst. Now, in my Kaggle, in the Kaggle website, there's this stroke prediction data set. You can download it. Now, when you return to my screen here, all right, there are some job or some questions we want to answer from these data sets, things that a data analyst should provide answers to. Okay, now we said introduction to this project. We are diving into an insightful data set analysis on one of the most critical health concerns worldwide, stroke. Strokes are a leading cause of death and disability, and understanding the patterns, the risk factors, and correlations can help us make informed decisions about prevention and treatment. Now, if you see my screen here, the problem statement is stated. The goal of this analysis is to explore a data set that captures key variables like age, gender, lifestyle, and medical history to identify patterns and predators of stroke. So when we uncover this data, we're going to discover potential insights that may aid in early detection or risk mitigation strategies. Now, you check the overview here. What are the steps we're going to take? We're going to explore the data sets, perform data cleaning, conduct exploratory data analysis, EDA. There we can present our findings. And we're going to use some questions. Now, I group these questions into two. The first group is the descriptive analysis and risk factor analysis. There are some questions we are going to uncover or we're going to answer from these data sets. Questions like, what percentage of data set has history of strokes? What is the male to female ratio in the data set? How does this relate to stroke occurrences? Based on this data set, is there a trend? Is there a pattern where male or female are more likely to have a stroke? Then smoking habits, or those who smoked, those who never smoked, or those who currently smoked. What is the risk factor? How does this relate to the risk factor of having a stroke? Cases like hypertension, heart disease, how does this correlate to stroke? What about BMI, average glucose level? Do these factors increase or decrease stroke risk? And these are fine questions that the data analyst should provide answers to, right? That is your job as a data analyst. Now, we can also do a predictive analysis. Here, we're going to use knowledge of data science to build machine learning models that can help to identify these patterns. Then we can actually give our recommendations. We can build an app, a machine learning model app that can predict the occurrences of stroke and factors that contribute to that. Now, we're not going to be doing this in this video, this predictive analysis here. I'm going to explain this in my next video. So in that video, I'm going to introduce myself as a data scientist. Now, let's stick to this first one, which is the descriptive analysis and risk factor analysis, and see how we can use our data to give answers to these questions. Now, as I have said before, this data set is from Kaggle. So I will walk you through the process of how you can import your data to work with. First and foremost, we're going to create a Markdown file. You can use escape-m for your Markdown file rather than instead of coming here to choose the file. And then we need to import our libraries. So let's say let's write this as import libraries. Let me tell you, please, I'm not very good. I'm not too fast at typing, so I'm going to type slowly. So please Forgive me for that. We'll type Shift Enter. What are the libraries we're going to need for our work today? We'll need Pandas, so we're going to write import Pandas as PD. We're going to need a NumPy. Okay, spelling error here. Import, good. We're going to need NumPy, import NumPy. We need Pandas NumPy for our data frames and whatever operations we want to perform here. Import NumPy as NP. We'll need our Matplotlib for grid visualizations. So every question we provide answer to, we don't just want to say, oh, they are more female, they are more male. We want to give a visualization. We want to present this with a visualization tool so that whoever is looking at our code or whoever we're presenting this to will easily understand. All right, so we import Matplotlib dot pyplots as PLT. We'll need Seaborn, another good library for data visualization. Import Seaborn as SNS. Now we're going to need more libraries, but for now we stick with this. As we progress, if there is need to add more, we can add it. So we'll say Shift Enter. Here we have imported our libraries. What do we do next? Escape M for your Markdown file when you press that on your keyboard. Please note I'm using Windows. So if you're using a Mac, your functions may be different. But here in this project, I'm using Windows. I had also forgotten to mention that I'm going to do this project with a Jupyter Notebook that is using Python. If you're interested in doing the same project with Excel, SQL, or other data analysis tools, you can see my other videos, but here I'm going to stick with Python. Everything from analyzing the data to presenting it, I just want to do everything with Python here, right? Let's write our next step. We say we want to import the data, or we can use the word load. Load the data, and then we'll press Shift Enter. All right. To load our data set, we need to give our data a name. So let's call it health underscore data. All right, equals. The code is pd dot read underscore CSV because our data is in the CSV format. Then we need to copy the path. So I'll go to my file. I already downloaded the data from Kaggle. Here it is. I can copy this file as a path, then return back here. Then we paste, Control V. All right, close this. We need to put R here so that we can tell Python to get this file from this path. So we'll put R, then let's get our data set. I encourage you to always copy and paste to avoid typing errors. Okay, so I copy this health underscore data here, paste. Very good. I will hit Shift Enter. Here is our data set. What do you notice? There are 5,110 rows and 12 columns. And here are the columns. Okay. And we have a mixture of different types of data. Well, we'll get to check that. We can get to check that. And this seems a pretty big data set. 5,000 rows is a big data set, although there are data set that has more than 5,000 rows, but this is a pretty big one. So this will be very good for analysis. Now, let's go back to our project's overview. If you would remember, we said we are going to explore. All right, yeah. Explore the data sets. Now, what does this mean? We are going to understand the structure, the variables, and any gaps or anomalies in the data. Now, as a data analyst, I would encourage you, whenever you're given a data set, right before you dive into answering the questions, please understand the data sets. Understand things that would give you prior information, things that will help you in your analysis, especially when you get to the exploratory data analysis, and in case you want to build a machine learning model for this same data set. Now, why is this important? So let's do our first step here. We'll create a Markdown file. Remember, escape M instead of coming here to choose a Markdown file. Then we are going to write explore, or let me use the word get used. So we'll say get used to the data sets or to the data. All right. So what are the things? There are some code, there are some functions we can use. For example, we mentioned there are different columns here. Let's specifically bring out the column names. So we say health underscore data, which is the name given to our data set here. And then we use dots columns. Will this work? Okay. Health underscore data is not defined. Ooh. You see why I always encourage you to do copy and paste. Capital letter H is what we use there. Let's hit Shift Enter. We'll remove this. Very good. These are the different names of columns we have in these data sets, and there are 12 of them. What else do we want to do? Remember, we're exploring data sets. We also want to see the data types that we have there. So we'll say, I do copy and paste to avoid errors and wasting of time. Dots health underscore data dot d types. D types gives us the data types that we have in this data set. We're going to hit Shift Enter. These are the data types we have in these columns. Now, if you would return here, these columns have different data under them, but what kind of data are they stored in? Would there be need for us to change the data types in each of these columns? For example, the column ID, it is an integer, gender is an object, where we have the stroke it is an integer, BMI is a float, smoking status is an object. Now, this gives you a very clear picture of what this data looks like. Then, another thing we can check, still on getting used to the data, is what are the statistical summary? Okay, so we say health underscore data dot describe. Describe. This will give us a statistical summary of the data set. Then we hit Shift Enter. Awesome. Only I will just focus on one column here. Let me use the BMI column. The mean value is 28. The standard deviation is 7.8. The maximum value is 97. The minimum value is 10. This is amazing. Now, if we're going to build a machine learning model for this, we're going to really pay attention to this a lot. But we're just in the statistical summary of this data set. What else can we do to get used to this data? I would also encourage you to check if there are missing values. First, let's just check if there are duplicated values. So we say health underscore data dot duplicated values. Shift Enter. Oh, this is giving us false, but it's just showing us 0 to 4 rows. Then it cuts it off from 5,000 plus rows to 5,109. We can't be sure. So we need to put a sum here. So it summarizes it. All right. If there is going to be any duplicated value to indicate, if there will be none, we're going to get a 0. Awesome. So there is no duplicated value in this data set. Are there no values? Are there missing values in any row? Let's check. So we'll do our health underscore data dot is NA. You can choose to use this null. You can choose to use this NA. And we'll return the sum If there is a null value, shift enter. There are no missing values in this data, in these row, columns, except for BMI. So if you can see, there are 201 missing values in the BMI row, BMI column rather. That means there should be 201 rows that has missing value, and they are all missing in the BMI column. Now, this is not really clear. There's something you can do here as a data analyst. You want to be interested in what rows do we have these missing values? Is it in the first 200 rows? Is it in the last 200 rows? Is it somewhere in between? Is it spread all across the data set? There is a reason why you need to pay attention to this. Now, you can use a heat map, right? You can use a heat map to check if there are missing values here, to know where we have the missing values, the rows where we have the missing values in the BMI column, right? So we're going to use a heat map to show this. You may be wondering, what code can we use to get a heat map that shows where these missing values are, what rows where we have the missing values? So we can use SNS. Remember, SNS is one of the Seaborn is one of the libraries we imported. So we say SNS does heat map, and we can return this function here. Aha, making it easy. And then we'll say, good. Then we close this. Now, sorry, what are we trying to achieve here? We are trying to get where we have these missing values. What rows do we have these missing values? Where do we have these missing values? We know we have the missing values in the BMI column, but is it spread all across the data set, or is it the first 200 rows? Remember the question we're trying to find answer to. So we hit Shift Enter here. Awesome. Here's our heat map. So you can see the name of the columns here, ID, gender, age. Then we look at the BMI. This is where we have the missing values. The whole of this dark space here means there's no missing value. But when we check here, we have missing values. Then what do you notice? It is spread across different rows. For example, we have a missing value in row 197. We have missing values in these rows mentioned here. So it cuts across the beginning of the data set all the way down to the end of the data set. So here we have the missing values. So now this will help us this will give us an insight to what to do. Do we drop the missing values? Do we replace them with the mean value or the median value? We'll get to decide that when we get to data cleaning. This is getting interesting. So we know where our missing values are. We've seen the if there are duplicated values and there is none. We've seen the statistical summary of our data set. We've also been able to check the data types, the column names, and so on. Now let's return back to our project overview. The next step is going to be to clean the data. We've gotten used to the data. Now let's clean the data. You see, this is where your work as a data analyst gets more interesting. You need a clean data for you to work. I also have checked the outliers here, but I'll choose to leave it for now. But let's go straight to cleaning the data set. We're going to hit Shift M for our Markdown file, and then we'll write our next step. We say clean. Yeah, clean the data. Awesome. Shift Enter. All right. First, I like to always have a view of my data sets once again. So we say health, health underscore data and dot head. Let's see. All right. Shift Enter. This is our data set once again. You can see right here that we already have missing values here on the BMI. So we might be interested first and foremost in doing something about the missing values. Now, this is what we can do. We have two options. We can choose to replace the missing values with the mean of this BMI column, or we can use the median of this BMI column to replace the missing values. We can as well choose to drop the missing values. Now, this is where it gets interesting. You see, when you put the mean value or you put the median value, it is an assumption. Okay, I'm going to assume that if the mean value here for this data BMI column is 28, for example, I'm going to assume that the 200 missing BMI values in this data set are 28. That's the mean value. It's an assumption. I can as well decide to drop. Yeah, I can as well decide to drop these missing values. Now, what decisions will I make here? I choose to drop the missing values, and the reason is since there are 201 missing values in the data set that has 5,000 plus rows, removing 201 will not necessarily affect the information conveyed in this data set. I get to tell you why. So let's say we want to drop our missing values here, health underscore data. Okay. I remember I said copy and paste. Copy and paste gives you less chances of typing error. Health underscore data. Then we use the drop NA. So drop NA. Let's see. Shift enter. Amazing. We've been able to drop the 201 rows with the missing data, and that returns 4,909 rows as against the 5,110 rows of the original data set. Isn't that interesting? So we'll drop the missing values on the BMI column. Now, if you would check our data once again, our health underscore, okay, copy. Yeah, I like shortcuts. Health underscore data, shift enter. You would notice we still have 5,101, 110 rows. But here, when we drop the missing values, we have 4,909 rows. So how do we affect this code, this drop NA to reflect on our data set? We just return back here, very simple. It's like, I'll use the word, I want to replace all missing values with nothing. I don't want to see any missing value in data. So I use the word in place. In place equals true. What will that give us? Shift enter, and then we check our data set once again. Shift enter. Health underscore data now, we have 4,909 rows, 12 columns. We'll drop all the missing NA. For you to be sure, you can just check that once again. You say, to check, we can easily check the missing values once again. We'll say dot sum. Then this will tell us if we still have any missing values. Awesome. So there's no missing value here. All the data set is complete. There is no missing value. There is no NA in our data set anymore. So we've cleaned this data set. What other thing can we do? Should we drop any column? For example, we will not be needing the ID column here. But since we are not doing machine learning yet, we can just retain, we can just leave it. So that is it. We've cleaned the data set. Now, what is the next thing on our project overview? We said we are going to explore the data. And this is where you as a data analyst, this is where you speak your language. This is where you tell your stakeholders, your supervisors, this is where you give them the report. From this data, here is what I have found. And you're not going to say it's just vocalizing it or just, you need to show them. They need to look at the screen and understand what you're saying. So this is where your job as a data analyst comes into play, right? So we say, let's create a markdown file, escape M, and we're going to type perform, or let's use the word EDA, which stands for Exploratory Data Analysis. So we say Exploratory Data Analysis, all right, analysis. Shift enter. For us to do this, let's return back to those questions that we are to give answers to. Our stakeholders want to find answers to these questions, and here as a data analyst, we want to present these answers to them. So the question we want to give answer to first is, what is the distribution of strokes across different age groups? So we copy this here, question 1, and when we return to our data set, to our workspace here, we can paste the first question. So we still need a markdown file, escape M, and we're going to write this. Okay. And then we paste. Oh, awesome. First question. Shift enter. What's the distribution of strokes across different age groups? First and foremost, I always like you to look at your data set once again. We have different age groups here. We're 67, 80, 81, 13. So in what way do you think we can best present the answer to this question? Well, one of the things we can do, amongst many other things, is that we can use a plot, which is a histogram, to show the distribution of age across the different age group in this data set. So we can say SNS. Remember, SNS is one of the libraries we imported for data visualization. Then we use the word hisplot. Hisplot. This will give us a histogram. And we fit in the conditions. We want this histogram to show us the age distribution. So we can say health underscore data, which is the name of our data. And you can create the square brackets here. We say we want to talk about the age. So we'll put our age column here. Remember to always check for spellings. And that's why I advise you to copy and paste. So age is very easy to spell. So I've typed that. Then we close this, our square bracket here. And what is? We would put KDE equals true. You can read about his plot to understand what this KDE means. We just want to show how it is distributed. We want to draw a line to show how it is distributed. And we can close this. Our histogram needs to have a title, right? So we'll do plt.title, and we'll call this distribution of, oh, well, let's use the word age distribution. Shorter the better. Age distribution. All right. Let me close this. All right. And okay, we're going to have an X label. We do not need a Y label because Y label automatically be the weight is distributed. So we'll put plt.x label. X label. And we can call our X label age. Age. Yeah. Age. Then we close this. Okay, we want to say, we say plt.show, and we'll return the visualization. We hit, okay, shift enter. Error. Module Seaborn has no attributes. Is pp plot typing error. Sorry, we'll delete this. Then we'll hit shift enter once again. Awesome. Here, we've seen the distribution of age group. We've seen this data set starts from 0 years, should I use the word 0 old? Okay. Babies, newborn babies, all the way to older ones here, 82 or 83 thereabouts is the highest age here. So we've seen the age distribution, right? Now, it simply means this data set cuts across different ages. And if you would notice here that it's like from 0 all the way to 82 or 83. Now, the question will be, where do we have the cases of stroke? Is it between people that For individuals that are 20 years and above, or 20 years and below, or those who are above 40, those who are yet to be 40, or those who are old, like those in their 60s, 70s, 80s. Yeah, data analyst should give the answer to that question, right? So let's twist this um, histogram a little bit to show where we have stroke across these different age groups, right? So to do this, we would say, let's just write what we're going to do here. We'll say relationship between age, and stroke. Okay. So we're going to plot the same histogram. Remember, I always encourage you to copy and paste. We're just going to change some little things here so that we can show where we have the cases of stroke. So we copy this and we paste it here. Then we'll do some little changes here. We're going to change some of the write-ups here. So we'll say we're still using our hist plot. SNS does hist plot. Then we're still using the data, which is our health data. And let's just change some little things here. So let's say health data, which is the data we're using, we'll give X equals the age column, age, and our Y equals the count of stroke. But here we can use hue. So we say hue equals the stroke column, stroke. All right. All right. Then we want to stack it. So we can use the word multiple. Multiple. Equals stack. Since we're going to have it stacked on where we have, for example, let me just give you a picture of what we're trying to do. Here, we're going to say, okay, those who are 40, if there are cases of stroke here, we want to indicate those who are 60 plus, those who are 80. If there are cases of stroke here, we just want to indicate where they are. So let's continue to give our conditions. We can stop here for now. And age distribute, let's change the title a little bit. We'll say stroke cases by age. So it says stroke cases by age. Okay, this is a beautiful title. Now, we are going to have a legend. So we'll say PLT.legend, legend. Okay, all right. And here, the legend will have a title, right? So we'll say title for the legend. Let's call it stroke status. Say stroke status. Good. And what else we want to have in the legend? We'll say the labels. The legend should always have a label. So we'll say labels and open a square bracket here. If there is stroke, if there is no stroke, we want to have a no. And if there is a stroke, we want to have a yes. All right. So we'll say yes. I know you are curious. What would this look like? Don't worry. X label. We do not need X label anymore because we already give the X as age here. All right. Hoping there's no error here. Let's hit Shift Enter. Ooh, something is cooking here, right? Now you notice our histogram has changed, right? And what do you notice? Remember, look at our legend. Oh, this should be yes and no, not no and yes. So put this as yes, and we put this as no to make it clear and understandable. So yeah, hit Shift Enter once again. Good. The orange color here in this our histogram are cases where we have age group where we have stroke, while the blue completely represents cases without stroke. This should give you a very big, a clearer picture of this data set. In these data sets, there are individuals, there are cases without stroke. There are more of them here. All right, but let's focus on what we are looking at. Stroke cases by age. Those who are in their 40s and above are likely to have a stroke. So the older a person gets, the higher the risk factor of having a stroke. Yeah, that's what the data is telling us. That's what we're saying. And those who are between the ages from being a newborn baby to probably somewhere around 28, 27, they do not have any case of stroke based on this data set. So it simply means the risk of stroke increases by age. That means the older a person gets, those who are in their early 60s, all the way to those who are in their late 60s, they are more at a high risk of having a stroke. Do you still remember the question? The question once again is, what is the distribution of strokes across different age groups? What's our answer? Yeah, answer is here. Here we see it. Here in this our visualization here, we've seen that those who are from 37 upward, whose age are increasing, all the way to those who are above 80 are likely to have a stroke. So this is where we have the record of stroke cases. So age is a factor, is a risk factor in these cases of stroke. The older a person becomes, the more likely the person will have a stroke. Oh, this is interesting. A data analyst should be able to speak this language of interpreting and making stakeholders to understand their findings so that they can make informed decision, right? So let's answer the second question. What percentage of the data set has a history of stroke? This is rather very easy. This is a little mathematics can provide answer to this. But as a data analyst, we do not want to stop at just the mathematics. We want to give the visualization. We want to have our audience or our stakeholders see it for themselves, the language of the data. So let's answer that second question. We'll create a markdown file, escape M, and we say, we'll paste the question here. What percentage of the data set has a history of stroke? Shift Enter. What we can do here, we can just do a little mathematics. Let us count the number of persons with stroke here. So we'll return our data set once again, health_data, health_data. Very simple. We can just do dots value underscore value. Yeah. Value underscore counts. And what are we counting? We need to indicate the column we are counting. Here we're counting the column where we have the stroke. And then we say, just create, very simple, create a square bracket here. We say stroke. Close this and close this. What will this return? Shift Enter. Amazing. 0 represents, if you read up about this data in the Kaggle dataset where we downloaded it from, 0 represents no stroke, 1 represents stroke. Now you see we have 4,700 cases of stroke, 4,700 no stroke, 209 cases of stroke. So of the 5,000 plus data set, which we reduced to 4,909, we have just 209 cases of stroke. What does that tell you? Data analyst, you have to start thinking. This is an imbalanced data. there's going to be quite a number of bias in this data. And before we can say, okay, stroke, we have hypertension will cause stroke, this one will not cause stroke, blah, 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 before we can give those answers, we need to recognize and accept that this our data set is not balanced. It's not even half, just 209, and then 4,700 cases of no stroke, and then just 209. Well, you want to do more as a data analyst. You don't want to present this to your stakeholders. So we want to present a visualization, we want to show this in a diagram or in a picture, yeah, whatever word you want to use to our stakeholders. So we can choose to do a bar plot, we can do a pie chart, but I will do a pie chart so that I can answer the next question right away. I can say 5%, 10%, or 20% of this data set are cases of people with stroke, and maybe 80% or 80-something% are cases of people without stroke. So we can use a pie chart. So let's quickly do that. Present this in a pie chart. Let's just type that. Presents it in a pie chart. Now, let's proceed right away to make a pie chart. Remember, as a data analyst working with Python, code, you don't write code. But if you have a mental picture of what code you are writing, that will help you be quick to think about the right code to use, right? So let's do the pie chart here. So we'll say plots plt dot pie. Okay, we need the pie chart. Now let's give our conditions. We will need the stroke counts here. So let me write stroke counts. Stroke counts. Okay. I think I also have done that first. Okay, let's quickly write that here. We will refer to this as stroke counts. So stroke underscore counts equals this our code here. So we hit shift enter. So that gives us what the stroke count is. But since it's a pie chart, I always like to make it easy. So I'm going to copy this here, stroke underscore count, and let's define this. Stroke count equals, we have, open your square bracket. Okay, we just hold on a bit. Let's see what our stroke count is first. We need to put this here. Then we'll hit shift enter. All right. Stroke counts, we have 4,700, and we have 209. Good. And we need to give the labels. Let's call this labels so that we can put these conditions here in these brackets here. So labels equals, if for 4,700, we're going to use no stroke. Very easy. No stroke. No stroke. Very easy. And for the 209, we'll refer to this as stroke. Oh, awesome. Then we can close this. So we are plotting the stroke counts. You put your comma here. And the labels, we don't need to repeat that again. We just write labels equal to labels. Interesting. Then, since we want the pie plot to give us the percentage here, so we're going to write auto PCT equals, this is a little bit difficult, but you can always remember this. The more you get used to it, the more you remember. We'll say shift, need to create this first. We'll say %1.1f, and we add the 2%. This would confidently give us the percentage of cases with stroke and cases without stroke, right? We can leave this way. You can always add more things, but you can leave it this way. And What else do you want to put? We want to have a plot title. So plot plt.title. Yeah. And what do we call this? We say distribution of stroke cases in the data, or let's just use one simple English. We just say distribution of stroke cases. This should work. Sorry, it should work. And we need to show our plots. So we put plt.show. Awesome. Hope we don't get an error. So let's hit Shift Enter. There's no error. Oh, amazing. That means 4.3% of individuals in this data set have stroke. 94.7% do not, 95.7% do not have a stroke in balanced data. And now the expectors, the stakeholders expect us now to give recommendations to answer their questions, to satisfy their curiosity, and they've given us an imbalanced data set. Data analyst, your work has just begun, but that is why you're an analyst. That is why you are a data analyst, to give answers to these questions. So we've answered this question here. The question once again, remember, what percentage of the data set has a history of stroke? Very easy answer. We say 4.3% of the data set here have a history of stroke. Do you recall our next question? Let's return to our project overview here. What is the male to female ratio in the data set? How does this relate to stroke occurrences? Interesting. So we copy, and then we'll create a markdown file here. Markdown file here. All right. Don't worry, it's looking big. And big. All right. So create a markdown file here. We'll do Shift Enter. Escape M first. Then we'll type Shift Enter. Awesome. Let's give an answer to this question. What is the male to female ratio in the data set? How does this relate to stroke? First, we want to count number of male and number of female in the data set. So we return our data health_data. Since we are counting, we'll say first create a square bracket here, and we'll put gender. Gender is the name of the column, right? Remember to put apostrophe here. Okay, gender. And what do we want to get from our gender? I want to count. So say value underscore counts. Shift Enter. Ooh, there are 3 genders here. There is female, there is male, and other. Okay, other should be those who are not male, who are not female. Okay, you should find a word to call them. But here we have female, and there we have male. Okay, female, there are more female here, 2,897. And as for male, we have 2,011. Interesting. Data analyst. Here we also have imbalanced data, right? When they were doing the interview, when they were conducting research, they had more female than they had more male. So one will automatically think, oh, that means there should be more female with cases of stroke. Well, it is your story to tell as a data analyst, and you're going to tell the right story. So here we've seen the counts for the different genders we have in our data set, and we've seen there are more female than there are male. But remember the question, how does this affect, or how does this relate to stroke occurrences? So let's give them the answer. All right, so data analyst, your thought process now should be, okay, this data is not balanced. There are more female than there are male. Okay, if I bring 1,000 male here, bring 1,000 female here, and I want to balance it in such a way that I want to put enough cases of stroke here, cases of stroke here. How do I balance it? Do I change the data set? No, you are not changing the data set. What you're going to do, you're going to use simple mathematics. And then we're going to use the mean value. Okay, the mean value simply means when we group the stroke cases and the gender, we want to equalize them using the mean value, and this should give us a picture. So I will call it stroke rates. Stroke rates across these genders. So say stroke rates equals. Okay, let me still use the word stroke rate underscore gender in case we want to use this for another column. We say stroke rate underscore gender. So what we are saying is, what is the stroke rate across the different genders? We use the group by function here. So first we'll drop our we use a health underscore data dot group by. This helps us to compare two columns. Group by, and the first one is the gender. So we'll say gender. All right. What is the count of stroke? So we say the stroke column, stroke. Yeah, close this. Then we will use the mean value. Mean value would give us the stroke rate. Now, when we check this, you would notice something very significant. This is where this is where you begin to tell the story as a data analyst. You say shift enter. Oh, the stroke rate across the female gender is 0.041. Male 0.044. Meanwhile, the counts of females in this data set, there are more, but the stroke rate in female is less than there is in male. Amazing, right? Data analyst, you are telling a story, right? No, let's do the overall stroke counts by gender. So I will use the word stroke counts underscore gender, stroke underscore counts underscore gender. Forgive me for using these long names. So how do we count this? Simple mathematics. We can multiply the stroke rate by the count of gender. Here we'll do this times this. So very easy. We can just say, we call this, do we call this a name? No, we can just leave it this way. So let's say stroke rate by gender, copy this. Yeah, simple multiplication, we paste, times, right? And then we just take this function here, which is very easy, copy and paste. Ooh. I hope you are still flowing with me, right? So return this, we'll say, then shift enter. Ooh. In our data set, female, number of female with stroke 120, number of male with stroke 89. But remember, there are more female than male in individuals in these data sets. So to answer this question, how does this relate to stroke occurrences? We are going to do something else. We can plot a bar chart, or we can use a pie chart to represent this. But what do you think? I want you to think about this as a data analyst. Based on these rates, the stroke rate by gender and the stroke count by gender, what gender do you think will have more cases of stroke? I want you to think about it. Now let's provide the answer to that question. So a very simple diagram to represent this. So we're going to plot a pie chart. Yeah, we can use a bar chart, we can use a plot chart. Let's say plt.pie. Remember, we need to give our conditions, right? We say, we want to plot this stroke count by gender. Stroke count by gender here. Okay, put it here. Awesome. And then remember, when you are plotting a pie chart, we are comparing two things, right? I want it to come out in form of a percent, or want it to be described in percentages, right? So we need our labels, right? Can put everything in this bracket. So we'll say labels equals stroke in male, stroke in female. Would that be right English? Okay, let's use stroke underscore male, and close this. We use stroke. I don't like typing. All right, we have stroke underscore female. All right, we'll close this. Oh, there are three genders. Forgotten? Sorry, no offense. Place those that do not identify as male or female. So we use other. Say other, and we can close this. Stroke counts underscore gender, and the labels we have stroke in male, stroke in female, stroke in others. Well, let's just leave it as others. And then remember, we need to get our answer in percentages. Do you remember that we say auto PCT, and okay, I always forget to put my apostrophe here. All right. Sorry, not here. Auto PCT equals, we'll say percentage 1.1f, then return it to percentage, and we close this. We can close this. We'll give it a title, plot title, plt.title. And that gives us, let's call it stroke rates by gender. So very easy, we'll type stroke rates by gender. Close this. Oh, you remember to put this. All right. And then we'll get our plot.show. That gives us our pie charts. What have we done here? Stroke counts by gender. Remember, it is here. And we want to fulfill these conditions by showing what percentage of male in this data set have stroke, female has stroke. Do we say there are more female with stroke than male? Even if data clearly shows that there are more female than male when we do the regular counts. So we hit shift enter. What's going on here? Oh, this is percent. I'm bringing that and sorry, you should type in error. Aha. Shift enter. All right. Let's see. Oh, amazing. The rate of stroke for the male gender rather, is 57.4%. And for the female, the stroke rate is 42.8%. What is the answer to our question now, data analyst? We are giving answer to our supervisor stakeholders. We say, how does this relate to stroke occurrences? Based on our data, even if the data is imbalanced, there are increasing number of stroke cases in the female gender, male gender here, that's what we call it stroke male, than there is in female. Well, I am seeing an error here. It should be stroke, not stroke. Don't like typing. Don't forget that. Shift enter. All right. Very good. So data analyst is giving the correct answer now to this question. There are more cases of stroke in male than there is in female. So men like me, we have to be careful. We have to pay more than usual attention to our age, to our health when it comes to stroke cases. All right. This is getting interesting, right? This is basically your job as a data analyst. Present your findings help its stakeholders to make informed decisions. Now let's go to our next question, right? We'll go straight to our next question. So we need to go back to our project overview. All right. You would notice we said the next question is, does the smoking status, this is going to be interesting. E.g., never smoked, formerly smoked, currently smoked. Does this affect stroke risk? Data analyst, provide the answer. Very simple. We'll return back to our workbook here, our notebook here. I will say we paste escape M and we hit shift enter when we paste this. Shift enter. Does the smoking status, e.g., never smoked, formerly smoked, currently smoking, affect stroke risk? You see, the amazing thing about working with Python is you can actually find let me use the word, a pattern of code to use. Let me give you an example of what I'm saying. You know, here we did it counts, cases of stroke, in male and female. Here we use this formula. See what you're going to do. You can just copy this and you adjust it. Yeah, it makes your work smooth and faster. Reduces the time you use to think. So instead of using gender here, what are we looking for? The question is for smoking status, but be careful to use the right word. So let me refer to one of our tables here. Smoking status. This is the spelling. When I was learning, I actually had problem typing. So I've chosen the part of, if you know what you want to type, copy it and paste it. So here we put count. So we count the stroke, different stroke status here. Shift enter. In our data set, we have never smoked, 1,852 rows. Unknown, those who don't know, who don't know their smoking status, whether they've ever smoked or they've never smoked, or if they formerly smoked, 1,483, formerly smoked, 837, smokes, 737. This is still not balanced. So what do? We need to create a balance. Remember the word I use here. If you return back here, remember we did something like this. You can copy this. Your work is to balance it and give a meaningful answer based on the insights from the data. So if we just go by days, one can easily assume, since there are people who have never smoked in the data set, we can say, well, stroke rate is not common among those who is more common among those who have never smoked, or we can just start guess, but we don't want to guess. So we'll call this stroke rate by smoking. Would that be correct English? I'll leave that question to my English teacher. If you're watching this video from Nigeria, I would have used a slang. I would have said, nah, the English is nice, but no offense, if you are not in Nigeria, if you don't speak Nigerian pidgin. So we'll say stroke rate underscore rate underscore smoking. So we want to know the stroke rate by the smoking status, if that is the correct English. All right. And instead of having gender here, we would have smoking status. Imagine someone walks up to you and say, what is your smoking status? Would you confidently answer that question? And let's return this shit. Unknown seems to have, let's be sure. What is the highest number here? 0.068. Those who have formerly smoked seem to have a higher stroke rate, followed by those who never smoked. And wow, data analyst, are you seeing the answer to that question? Well, we can't be too sure. Let's present a visualization, a diagram to show this, and this will make it clear. Remember the question? Does the smoking status, never smoked, formerly smoked, currently smoking, does this affect stroke rate? Like they want to know, those who smoke, those who don't smoke, what is their risk factor for having a stroke, right? So let's just plot this and present our findings. All right. We need to put this in a data frame. This will involve a lot of typing. Okay, let's put this in a data frame because I intend to use a bar plot since there are about 1, 2, 3, 4 categories. So let's create a data frame and we're going to call this smoking data, smoking underscore data. See, let's give the conditions. First, we would say smoking status, smoking rates. So if we want to do this, we can easily say, let's call this one smoking underscore status. Say smoking status. And would use equals the square bracket. We'll just have to copy these things that are here. I like to copy. I like to copy. Very easy. Which one is faster, copying or typing? Those that can type very fast, typing is faster. But for those of us that don't know how to type too fast, we'll improvise. Say, paste this here. And we copy this, never smokes. Copy. We want to create a data frame, remember? Like creating a new table. Yeah, that's the word. Smokes, copy. And we'll put it here. And then we can close this. Simple. That's not all. We have another condition. The smoke rate, we want to put this under a column called stroke rate. We can use Shift Enter here. You can just, I don't like to write long code. I'd rather break the code. I'm missing something here. This should not be an equal to. Yeah, this should be, this will work. Yeah, so when we hit, very good. All right, so we'll refer to this as stroke rate, stroke underscore rate. I'll read the name of the column, stroke underscore rates. All right. All right. So we'll copy these numbers. Copy you, Mr. Man. Come here first. Copy. Paste this. Yeah. And paste this. And we paste this here. All right. Then the last one, smokes. Copy this, copy. And we paste this. We close it. All right. We'll return our smoking data. So we just copy this and we put it here. Then we hit Shift Enter. All right. So we can now create our data frame. So let's call our data frame. Let's call it smoke underscore stroke. Right. So in this our data frame, we're going to have the smoking status as one column, smoking rate as one column. So remember the code pd dot data frame. So create a new data frame or a new table. And we put our conditions. We'll say smoking data, which is the name we give it here. Smoking data. And paste. Isn't that simple? All right. Then we'll return our stroke underscore smoke underscore. Oh, this is typing error. It should be smoke, not smoke. Smoke. All right. Smoke. Remove this. All right. Hit Shift Enter. Oh, this is our new data frame. So we can easily plot a bar chart to represent this. We can easily put a bar chart to represent this. And that will be very, very easy. Or we can as well use a pie plot. Whatever we choose to use, In this case, we're choosing to use a bar plot. So the same process, the same step, we say plt dot bar plots, bar plots. Then we'll give our conditions. We are plotting the smoke status. Let's first indicate what data we're using. But you can choose to write data equals simply the name of our table. Smoke. That sounds funny. Smoke underscore stroke, which is name of this table or name of this data frame. And we give our y, say y equals smoking status, which is here. That means our y-axis equals smoking status. And our x-axis, it is common to write y-x-axis first, but I choose to write y-axis first. Doesn't matter. We say stroke rate. Okay. Take it calm. I'm actually using a laptop and I'm not using a mouse. So that can give problems sometimes. So paste this stroke rate. All right. We can close this. We need a title for our bar plot. So say plt.title. And what title should we give it? We'll call it stroke rates by smoking. Would that be correct? Stroke rate by smoking status. Stroke. Okay, so let's say stroke. So I don't like that. Stroke by smoking status. Close this. All right, since we're going to have a bar plot, we need to indicate what our y-axis is and what our x-axis. Let's say plt dot x label. And remember, we already said x label represents the stroke rate. So we'll call the x label to make it look more beautiful. We'll refer to it as stroke rate, and the y label, plt dot y label. All right, and we'll refer to this as smoking status, which I can copy here. Okay, I can copy. We need to type smoking, smoke status, smoke status. Awesome. Then we close. Then we want to add plt.show. All right, shift enter. Oh, error, matplot has no attributes. Okay, why are we seeing this error? Bar plots. We should use SNS. Sorry, use the SNS dot plot bar plots. All right, shift enter. Beautiful diagram here. All right. The stroke status here, for those who formerly smoked, the stroke rate there is the highest. And for those who are currently smoking, that's the next highest one. And those who never smoked here, and those whose information is unknown, we should not look this when giving our answer because unknown can be anything. But here, we can rightly say smoking somehow increases the chances of having a stroke. But those who have formerly smoked, okay, I will use this word. They've smoked before, they've smoked hundreds of packs of cigarettes or whatever. Now their liver, their lung is getting weak. I'm not a doctor, I'm just saying this. So the chance of having stroke, especially if they are getting older, it increases. Why those who are currently smoking? their lung and their liver is getting damaged gradually. It's not damaged, but it's gradually getting damaged. They have another high risk factor of having a stroke. And those who never smoked can also have stroke, but it's not going to be like those who have smoked before or those who are smoking. Data analyst is giving answer to questions, right? Your work is intense as a data analyst. Look at the question again. Does the smoking status, never smoked, formerly smoked, currently smoke, affect stroke rate? The answer is yes. Cases of stroke or the stroke rate is the risk of having a stroke is kind of increasingly high among those who have formerly smoked, followed by those who currently smoked, and then we can now say those who never smoked can also have a stroke, but it is most common. The risk factor is with those who have formerly smoked and those who smokes. Data analyst, you can ask the question. Oh, this is getting interesting. Now let's look at our next question, which is how do features like hypertension and heart disease correlate with stroke? I'm really interested in finding answers to this question. So we're going to hit Ctrl+C, we copy this here, and we'll return to our workbook. We'll create a Markdown file. Remember, your stakeholders need to understand what you're doing. So we'll use escape M, and we paste and then shift. Enter. How do features like hypertension, heart disease correlate to stroke? Now, our notebook is getting big, and big. So let's just once again view our data set to say health. After letter H. Health underscore data. And we want to see the head and shift enter. So here we have hypertension, here we have heart disease. If you read up about this data on the Kaggle data set, you will know that 0 represents yes case of heart disease, 0 represents no case of heart disease, and 1 represents yes case of heart disease. Okay, so how does this two affect, or we use the word correlate? Correlate is a word that data scientists are more interested in, especially when they do things like linear regression and they find correlations. But here, we want to answer the question as a data analyst. So once again, we'll repeat just about the same thing we've done here. And remember, I said your thought process as a data analyst is more of, okay, I have used this idea to get this. Can I use this idea to also get this? All right, so we copy this and we paste. So here we're going to change smoking status and we are going to put hypertension. Let's talk about hypertension first. Hypertension. Hypertension. Right? Then shift enter. Imbalance data set. Here you are again. 0 for cases of individual without hypertension. So in this data set, some 4,448 individuals do not have hypertension, while 451 do have hypertension. And they want you as a data analyst to tell them if hypertension will affect the risk of having a stroke. Well, we're not afraid. We'll give them the answer. That's why we're analysts. So once again, you can copy this. Just about almost the same process, because this is more of a categorical data. So we paste this and we change some things. Instead of having smoking here, we have stroke rate by hypertension. Copy and paste here. If you like typing, please keep typing. Okay. All right. And we group by, instead of having hypertension, smoking status here, we are going to put hypertension. And then we hit shift enter. Something is missing here, comma. And sorry, not a comma. There should be an error. We'll remove the comma here. If not, we're going to get an annoying error. All right. And then we hit shift enter. What is the rate of what is the stroke rate across hypertension? We say 0, based on what we are seeing here, represents no hypertension. And what is the rate of them having a stroke? 0.03. And those who have hypertension, what is the rate? 0.133. And this is higher. What can we use to represent this? We can as well use a bar plot. Yeah, we can use a bar plot. And we can copy this. Or should we use, let's use a pie plots. Yeah, let's use the pie plots. A pie chart rather. So if we're going to use a pie chart, we just have to change some things here and would copy this. Would there be need to multiply? Do we need to do what we did for gender? Multiplying this by this. Okay, so what I'll do, I'll create another cell here, create another cell above, and let's just do some in-depth analysis. So if you refer back to what we did for the gender here, there was a place we did some calculation of multiplication. Where was it? Here. All right. So you just copy this code and let's repeat the same thing here. This is not necessary, but this is a lecture class, so you want to know everything, right? So let's put this here, and we would call this stroke count by hypertension. 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 And we put it here, and then we'll delete this, replace it with hypertension. And instead of having stroke rate by hypertension here, we'll just, by gender here, we'll replace it by hypertension multiplied by what we had here. So just to replace the words, the terms, replace, and good. Hit Shift Enter. Okay. And in the cases of stroke we have in the data set, 149 people do not have hypertension and 60 people have hypertension. So we can present this in a pie chart. So we use, instead of having stroke counts underscore gender here, we'll just do stroke count. We'll do stroke count underscore hypertension here, and we paste. Labels, instead of having stroke male, we'll just, this label is going to have a little twist. We'll say stroke. No, we'll use the word hypertension. I missed me to copy this again. Hypertension. Copy this and we'll write here hypertension, and we can use equals. No. Okay. Oh, all right. This may be a little bit confusing, but I will explain once we drop the. Okay. All right. And hypertension equals, yes. We don't have gender, so we'll come others here. We want this. Then we'll change this to stroke rate by percentage of stroke rates. Or let's stroke rate by hypertension. And I'm going to type tension. Ooh. Okay. Remember, labels hypertension, no hypertension, yes. Okay. Let's see what this will look like. I'm expecting an error. Ooh. Hypertension, no. This is the stroke rate. And hypertension, yes. This gives us a picture of what we're looking at. So this actually gives us stroke rate. This does not give us what we are looking for. This is just the counts. This is not what we are looking for. So I would not indulge this. Uh, let me suspend this. To suspend, let's just suspend this code. Let's suspend this code. Okay, let's do shift enter once again. All right, there are better ways to present this. So we're going to use a bar chart, and that will make it more understandable because the bar chart is looking as if we're just doing a normal count. So let's use a bar chart here. So a bar chart, yeah. So we use, remember, you can always reference if the formula you've plotted, and we can copy this to make our typing faster. But if you are very good at typing, please, it's good to type. Yeah. So the data we'll be using here is a stroke. Oh, we can just change this. We can just change this to stroke rate by hypertension, stroke count by hypertension. So let's use this. All right. Right. So we'll replace this with this. And our Y, on our Y-axis, we'll have stroke rate by stroke count by hypertension. Or we can use, okay, let's use this. We use the value and we use the index. Good. So let's use this stroke rate by hypertension. And we paste it here. But we are going to use, in this case, we are going to use, okay, let me explain this. Let me make it much, much easier. Much, much easier. Remove this. All right, we'll do the same thing for X. So we use dot value. No, let's use index, and we come here, and then we use, for the X, we use dot values. All right. Remember, I want to plot a bar chart to represent this, a bar plot rather. So the title is going to be stroke rate, stroke by hypertension. Hypertension. All right. On our X level, we'll have stroke rates, and then on the Y level, we're going to have okay. On the Y level, we're going to have hypertension. Then we'll add something here. All right. Let's make this very easy. We'll say, let's change this a little. We'll put X here, and we put Y here. That will affect what we'll write here. So on the X label, we're going to write, okay, we're going to write hypertension is equal to yes for 0. Hypertension is equal to no. Hypertension is equal to yes for 1. Hypertension is equal to no for 0. So we'll say hypertension, create another bracket here, and we'll say, very easy, we'll say 0 equals to no, and 1 equals to yes. All right, I will still explain this. Close this. Okay, can close this. See, all right. Then for the Y label, we can just say stroke rates. Oh, awesome. So let's see what this will return. Error, data source must be a data frame. Okay. We'll return back. Remember, I've told you as a data analyst, you do not need to be afraid of errors. Yeah, I mean that. I think the problem is coming from here. We do not need to indicate this anymore. We can say X equals to stroke rate underscore hypertension. The index, Y is the values. Okay, let's see if this will work. Awesome. So we say, what do you notice? There is an increasing rate of stroke for individuals that have hypertension. That is why we say hypertension for 1 is equal to yes. For 0, hypertension is no. It's not like those that do not have hypertension do not have stroke, but it is most common among those with hypertension. So there's a risk factor. If you have an hypertension, you are at a higher risk of having a stroke than someone who does not have. Let's recall the question. How does hypertension and heart disease correlate with stroke? Right. So let's talk about that of here we did for hypertension. So let's create a markdown file to indicate what we did here. Let's create a markdown file here and escape N. And then we'll say hypertension. All right. Shift enter. All right. So let's do that of heart disease. So create another markdown file here. And we do heart disease. Shift enter. You see, now this is the secret I've been trying to tell you. For data sets that is as I'll use this is very simple data set that has categorical values. We can just use almost the same code for everything. We'll start from here, we can copy this and then we'll change. Okay, let's use the one we just dropped now. Very good. So we'll start from here. We'll copy this. Instead of having hypertension, we're going to have that of heart disease. And here we'll remove hypertension. Remember to always check your data set to use the right word and right spelling. So we'll have heart underscore disease. Heart underscore disease. We copy that. And we use it to replace this. Say, no. Oh, I'm going to type heart underscore disease. Right. Shift enter. Okay. Just like we have in the case of hypertension, there are less cases of people with heart disease, imbalanced data. So let's try to balance it. Remember what function we use. We'll group by, then we'll take the mean value. We'll say it was almost the same thing we did for heart hypertension. So we'll change this to heart disease. Heart disease. Maxwell do not like typing. I hope. All right. I really want to improve on my typing skills. Underscore heart underscore disease. I really want to improve on my typing. So if you know what can help me improve on my typing, please in the comments below, in the comment section, you can just add it and I'll work on it. When I was in school, I do not like writing as well. And now, computer, I don't like typing. But you cannot be data analyst without learning how to type. So that is my bad. I lost. All right, this is the rate. Still similar, there is increasing rate of stroke cases for those who have heart disease, and doctors can confirm this. All right, so we're going to plot the same thing here to represent this. Copy. And then we'll plot a bar chart. So here, stroke rate underscore hypertension. Here we're going to have stroke rate underscore heart disease. We'll use the index, copy, and we paste here, all right? And then the value for the y-axis, we copy and paste here. And then stroke rate by, we're going to use heart disease, heart. All right? And here we'll use heart disease, disease. PLT show, it should work. Error, stroke, SST. Where do we have SST? Type in error. Maxwell, do not like. Oh, awesome. So this follows a similar trend as well. Those who have heart disease have a higher rate of having a stroke, and those who have hypertension have a higher rate of having a stroke. So that gives the answer to our question here. How do features like hypertension and heart disease correlate to stroke? All right. Can you answer the next question? If we return back to our project overview here, okay. Is there a relationship between BMI, that is body mass index, and stroke? Do higher or lower glucose levels values increase stroke rates? So what I will do, I will just copy these two questions. These are the two questions we are going to answer. And this is where the word outliers come in. Now, in a data set, if you understand what outlier is, you know that not everything you have in your data set will give you the information you need. Outliers are like, let's say in a class in Nigeria here, there's something we call JSS1, and it is expected that those who are in JSS1 should be those who just left primary school and who are just entering secondary school. So we're expecting ages like from 8 years old to probably 12, 13, 15. Now imagine when you now have someone who is 60 years old in JSS1 or a baby of 4 months in JS1. How do you answer questions like questions like what age of individuals or teenagers or youth should we expect in JS1? You can't answer that kind of question. So answer that kind of question, you need to remove the outliers. You need to remove those who are almost 60 and the newborn babies of 4 months. Then you remove those outliers. Those are outliers. Then you replace or you will use the common range, right? So in this case, to answer this question, right, we are going to remove those outliers. And this is where we're going to use a very beautiful function, a kind of box plot. So let's paste the question here, and then we'll do shift escape M, and we would paste the question. Okay. I think for now we'll answer the first one. So here we would remove this. All right. Let's remove this. Awesome. All right. Body mass index. Once again, let's view our data set. Remember, I always encourage you to view your data set. That will give you, that's like telling you, hey, I'm here. You should look at me more often. Yeah, you need to look at a data set more often as a data analyst. Head, and we'll return this. All right, so we're looking at the BMI column. This is the column that we should have had problem, but we remove the missing values. And you can see there is a range of numbers here. So what we can do, we can actually plot a box plot so that we can see the outliers and then focus on, yeah, so okay, I would use this word. I would say, first you need to identify the outliers. Let's say we use SNS. Here, I can use this to explain those outliers. Box plots, we use a box plot, then we'll give our conditions. We say, on the x-axis, we want to have the stroke column, stroke, right? And on the y-axis, we want to have BMI column, BMI, body mass index. And what other conditions can we give? What data are we using? I'm just trying to change this a little bit. So you can just maintain the same process of code we've been using. So we'll say data, you can choose to write data equals our health underscore data table. You can choose to use this. You can just choose to write it directly as well. And when we close this, by now you should have gotten used to what we'll do next. We'll need to indicate the title. So we'll say plt.title. All right. All right. And we'll call it BMI by stroke. Let's say stroke cases by BMI. Say stroke. Stroke by B. Let's use capital letter BMI. All right. And we need to have we need to give our X label. We say PLT X label. Now this is going to be a little bit interesting. You will notice how I will change some things here. We say for where there is stroke, for case of stroke, we need to give a condition. So we say for where there's case of stroke, which is 1, we'll say stroke. Okay. And where there is no stroke, which is 0, we will say no stroke. Okay, don't come in, you say no stroke. Awesome. Let's close this. And sorry, we needed to close this, then close this. All right, then let's look at our Y label. So Y PLT dot Y label. All right, do not forget to recommend typing class for me. Y label with BMI. All right, then PLT dot show. All right. All right, what we're saying is we want to see a box plot where we'll say, okay, the cases of stroke here, cases of no stroke here, we want to see what is the effect of BMI on the cases of risk. Is the BMI a risk factor? Shift enter, no errors. Let's take a look at this diagram. For where we have 1 here, where we have stroke, that's why we said 1 stroke, 0 no stroke. But for the just because of those who are reading or looking at our project, we can just change this to no stroke so that it can be clear, it doesn't get confusing. Put 1 here and we'll leave it as stroke. All right, return Shift M. Amazing. Okay, let me explain the outliers. Now here we have these outliers. We will not really consider them, but this is where our focus is. This is where we are comparing. Now, cases of stroke, 1 for yes, no stroke, 0. Now, what do you notice? Those who do not have stroke, whose body mass index is between 20 to 40, they are here. Why those who have stroke, in this our data set, the cases of stroke, all right, those who have stroke, between the BMI 20 to 40 is almost the same. What does this tell you? BMI is not a risk factor. We cannot consider the outliers here because look at the comparison. So we should not look at it here. Now we're looking at here. BMI is not a factor because those who have stroke, whose body mass index is between 20 to 40, we have the numbers there. Those who do not have stroke with the same body mass, we have the numbers here. So this removes the outliers, right? And from what we can see, the question is there a relationship between BMI and stroke? The answer is that the BMI do not really affect it's not a risk factor in having a stroke. just like we are seeing here. Now, let's take the second question. Is there a relationship between, we can copy this, then we can change it here, glucose level and stroke, and create a markdown file, right? Chips. We'll change it to average glucose level. All right. And stroke. Awesome. So we'll do the same thing for glucose level. We'll also check for outliers. You can use a scatter plot for this. Yeah, you can use a scatter plot for this. I think I will add that. But let's do that of glucose level. So copy this. Remember I said one way of getting something in using a Python for your data analysis is that there's always a way to add up, all right? So we'll say box plots, stroke, instead of stroke here, we'll use average glucose level. Let's see how it is written in the data set. More reasons for me not to type copy. And we paste it here. And we'll change this to average, or let's say glucose level. Glucose level. You know, when we say glucose level, I believe that is referring to being diabetic, high sugar level, something. So here we're going to write average AVG, then we'll write glucose. I don't know, just write level. All right. And plt.show. Remember, we're not looking at the outliers here. Here is our focus. Is this the same thing as the BMI? Absolutely no. Now, as the glucose level increases, we are also having increasing cases of stroke. For those who do not have stroke, whose glucose level are here, we can say, well, it doesn't matter. But for those who have a stroke, there seems to be a pattern. There seems to be, yes, as the glucose level increases, the risk of having a stroke also increases. Yes, remember here we have outliers, so we're not going to use the outliers. So to answer that question, for glucose level as it increases, increase in glucose level, or you use the word blood sugar level, or I'm not a doctor, I can say diabetic, those who are diabetic patients, or those who are diabetic, let me use the word diabetic. I'm not saying that is correct, but those who have high sugar level, high glucose level, they are likely to have a stroke because there is a connection between stroke and increasing glucose level. So they are at higher risk, but body mass index do not really affect. Interesting, right? So we've answered all these questions. There are other questions you can answer, like if you look at our data once again, one can ask you, what's the relationship between ever married, work type, and stroke? You should give answer. Or we can change the question to, how does age, hypertension, and heart disease affect stroke? We can build a correlation, a machine learning model for this. And that should be the next thing, predictive analysis, where we would build a machine learning model that can predict if an individual has a stroke or not, or if an individual will have a stroke or not. Predictive analysis. We can also do prescriptive analysis, but those would be under the machine learning model. And we've been able to answer these questions. Now, if you liked this video, if you like the teaching pattern, I try to make it very slow for those who are at the beginner level. if I was going to teach this to those who can code or those who know how to use Python or Jupyter Notebook, I will not be writing those code. I'll just show you this is the code and this is what you will get. All right. So if you find this video educative, please do not forget to hit the like button below. And you should also subscribe, because in my next video, I will be doing a machine learning model. I'll build an app that can predict if someone will have a stroke or not based on this data set. Once again, my name is Maxwell Adigwe. If you want to contact me, you can use the information below. My LinkedIn link is there. My email is there. And if you're in Africa, if you're in Nigeria, I actually have online classes where you can book for it. Yeah, we can discuss that. Even if you're not in Africa, probably you can work with African time. I will not teach in the middle of the night if you are in Americas, for example. All right. So thanks again. Please like and share. And thank you once again. My name is Maxwell Adigwe. Do enjoy your day, your night. Thank you.